welcome back. Today I just wanted to do a geometric sum for you guys. This is one that I just pulled from one of the foundation exams. And honestly, some people are scared of summations, like geometric sums specifically, but I kind of like them. I feel like they're very straightforward. A lot of the other FE questions, you kind of have to spend time figuring out what the question even is asking you. And this question was literally just like solve this geometric sum. So looking at the sum, we have two summations. Oh, and by the way, like if you don't really know what a summation is, don't worry. Like if you haven't gone over it, your professor will go over it. But a really way I like to put it is a summation is like a for loop in the language of math. So what do I mean by that? As in, like, think about this as a for loop, right? The summation. And then in here is whatever our function is. And then this is our lower bound. So we have pretty much, this is a j, by the way. So this would be 4j equals 0, all the way up until j equals I, do all this stuff. So it's just like a for loop. I feel like it's simple explaining it that way. But anyway, so nested summation. We have two summations. Whenever we have something like this, we always want to do the inner summations first and then move to the outer summations. Just because it's almost impossible to do this summation before you do this one. I mean, I'm sure there's probably some crazy formula you can use, but no way I know how to do it. So also, we're looking at this is a geometric sum. What makes it geometric is that we have the changing variable as an exponent, pretty much. So whenever you see, a base with your variable and the exponent, that's a geometric sum, and then we have to solve it like this specific way. So the first thing we're gonna do is we're gonna set this, we're just gonna work on the inside right now. We're not even worried about out here. We're gonna expand this guy here. So what do I mean by that? I'm gonna say S equals, and then I'm gonna expand this, starting from, j equals 0 all the way to j equals I. So we go 2 to the 0 plus 2 to the first plus 2 to the third, 2 to the third, dot, 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 plus 2 to the I. Okay? And we can all agree that this is pretty much the expanded version of this. So when j starts at 0, we have 2 to the 0. Then j increments to 1, we have 2 to the 1. Then j increments to 2, and we're actually down 2 to the 2. 2 to the 2, sorry. And then j increments to 2, and then, all the way up to when j equals I, and then it stops. It says, okay, so this is the first step, just expanding it into a, form that we can solve it. And then what we're gonna do is we want to write this again, but with one extra term, pretty much. So we want it to go to the 2I plus 1, pretty much. And the way we do that is we're gonna look at the base, and we're gonna see the base is 2, and then we're gonna multiply both sides of the equal sign by 2. And I'll show you what I mean by that. So now we're gonna have 2s, because we're multiplying the whole thing by 2, so we have to put on 2 on this side. And then think about it, if we multiply this by 2 to the 0, it's just gonna become 2 to the first. So we'll do that. So we're gonna actually start at 2 to the first. And then when we multiply 2 to the first by 2, it's gonna become 2 to the second. So we're gonna go plus 2 to the second. And then we're going to go, dot, dot, dot. And then we're gonna have plus 2 to the I. And then since we multiplied the whole thing by 2, that's gonna add one extra term. And it's gonna say plus 2 to the I plus 1. Okay, and sorry, I wrote them kind of close together. Let me separate them. Okay. So we can see that this expanded form is just this expanded form multiplied by 2. And then, okay, so now what we're going to do with these two s's is we're going to just solve for a single s, if that makes sense. So we need to get this back to just s by itself. So what we're gonna do is we're gonna subtract 1s from 2s. So we're gonna have 2s minus s equals, okay, and so we have 2 to the 1 minus 2 to the 1, so those cancel. So notice how pretty much what's going to happen is that all of these are going to cancel, and we're just going to have 2 to the 0 and 2i plus 1. But remember, we're subtracting this guy from this guy, so we have to put a net. So we have to turn all these, we have to turn all these to negatives. Because we're subtracting this now. And so these are all going to cancel, and then all we're going to have left is 2 to the I plus 1, because this term doesn't have that, and a negative 1. So we're going to have 2 to the I plus 1 minus 1. And this is the answer to this inner summation, okay? So we're getting somewhere. And then now we can rewrite this without this summation on the inside since we solved for it. Let me get my eraser. And I'm going to erase this. And I'm going to plug this in right here. So we have 2i plus 1 minus 1. 2 to the I plus 1 minus 1. All right, so now we have this guy here. So we see that we have another geometric sum. So we're gonna have to do that same process over again, but we also wanna see that we have this minus 1. And there's a nice summation rule that whenever you have like addition or subtraction inside of your summation, you can split it into 2 summations. You can almost like factor out the negative. So let me rewrite this as two summations. So it's going to be I equals 0 to the n to the 2i plus 1. And then, we're writing this as its own summation. So we're going to go minus, and then we're going to go the summation of, and it's just going to have a 1 on the inside. And it's the same bounds. I equals 0 to the n. Okay? So we're just using our summation rules to rewrite this guy as 2 separate summations. And this way, when we're doing it like this, we kind of solve either one we want to do first. Notice how it's not nested. The summations aren't being multiplied by each other. So we can solve either side first. But I'm going to stick to the 1 because I just think it's easier, get it out of the way. And really with this is, we just have to remember there's a specific rule for whenever you have a summation with a 1 on the inside of it. Whenever you have just a 1 on the inside with no variable, it's b minus a plus 1 is the answer it's the closed form of that summation. So me writing that, so we have b, so this summation equals b, which is n minus a, so minus 0 plus 1. So now I'm going to erase this guy and I'm going to write that in there for it and just plug it in. we have minus, it's pretty much just n plus 1. So we're getting somewhere. This is, our closed form is starting to come together. This is going to be part of our answer. And now let's do this geometric sum over here. It's like, okay, so how did we do it the first time? First we expanded it. I was like, all right, so let's just expand. So we have s equals, and so I starts at 0, but there's this plus 1, so it's going to start at 2 to the first. So it's going to be 2 to the first, plus 2 to the second, plus 2 to the third, dot, plus, and then it goes all the way up to n, so it's going to be 2 to the n plus 1. 2 to the n plus 1. So this is s. And it says, all right, now, how do we get, the next term? Is we have to multiply s by its base, which is 2. And just, in this problem, we're multiplying by 2, but I want you guys to know that it's not 2 every time. It's whatever this number is. So if it's 3, you multiply by 3, and then once you do your subtraction, you have like 3s minus s, which is 2s, and then you have to divide the whole right side by 2, if that makes sense. You always just have to solve for s at the end. So let's write it again with one more term. So that's going to be 2s. And then, okay, so if we multiply this by 2, it becomes 2 to the second. So we have 2 to the second. And then multiply this by 2, it becomes, multiply this by 2, it becomes 2 to the third. And then we multiply this guy by 2 and it becomes 2 to the fourth. So I keep writing them so close to each other. Let me rewrite this real quick. There. 2s equals 2 to the second plus 2 to the third plus 2 to the fourth, dot, plus 2 to the n plus 1. And then our next term is 2 to the n plus 2, if that makes sense. Okay, so now we have 2s and we have s. And it's like, how do we solve for s there? We can just subtract s from 2s. And so we make s negative. And then these all become negative. And we can see that these are going to cancel out. These are going to cancel out. There is a 2/4 term in here that would cancel it out. And then this would cancel it out. And this is going to cancel out. So then we have s equals it's going to be 2 to the n plus 2, because see how this is remaining, and then we still have a negative 2 in here. It's going to be minus 2. So sweet, now we can plug that in for this summation. So let's go and do that. So remember, this was 2s minus s, and that's how we got that. Okay, so we erase this. We plug in what we got for our answer, which is 2 to the n plus 2. Need more space. Focus. Let's write it backwards. So we have minus 2 to the 2 to the n plus 2. And then, we simplify. We have 2 to the n plus 2. And then we're going to have minus 2 minus 1, so it's minus 3. So actually we're going to do just this minus n first. minus and minus 3. And this is the closed form of that first summation we had. I hope this helped. I know like summations, you know, that may have seemed like a lot of work, but you know, that was pretty much because we did 2 summations, since it was the nested one, and we did 2 geometric ones. But the steps are I think are very simple, and I think it's a lot more straightforward than the rest of the foundation exam. And I hope if you guys get like a geometric sum on your FE that